Okay, so what we want to do now is look at a study of sitting posture and the controls. And what was evaluated in this particular study was 3 different postures, and they compared the anterior displacement of the head relative to C7. They also took a measure of the angle, thoracic angle and lumbar angle. And then they also took EMG, just a global EMG reading in the neck and at T4, so somewhere around here. And so what we can kind of learn by this is looking across it is how positioning of the thoracic or the lumbar spine affects the head. And so essentially this is kind of more of the thoracic's more of a kind of neutral lumbar spine with the thoracic spine extended. And this is more like a normal sitting posture. This is a slumped position where the lumbar spine is flexed, okay, and then the head has to kind of slouch forward or protract in order to keep the chin level. And then here we have like a very upright or anterior pelvic tilt of the pelvis in causing an extension or lumbar lordosis here in the lumbar spine, and how that affects the seated posture. And the key thing here for the neck is this distance from C7. So this is the C7 vertebrae, here, and here. And this distance here to the center of mass of the head is giving you the flexion moment. So you have a moment here, flexion at C7. So there has to be some pull here in the body, so the force and the erector spinae muscles to balance that. And so essentially the distance here is the moment arm that we're concerned about in terms of sitting posture. And so if you look across the different postures, you can see this distance is much higher here for the slump than either the thoracic or the lumbopelvic posture. So one of the key variables is this anterior translation of the head relative to the vertebrae, and that change in the posture for each position. And so if we kind of look down here, then we can kind of see the results of the study, and we have the data for each one of the postures. And so essentially the change in position with slumping was about 3 centimeters as compared to like a control position. And then it went actually the opposite direction for the thoracic spine. The head moved backward 1 centimeter. And then for the lumbopelvic, there was no change relative to the reference position. And so essentially the take home there is that there's a 4 centimeter change with forward head posture, because we've said that most normal postures is the thoracic. So something like 4 centimeters increase in the moment arm would account for the differences to slump posture, so the moment. So you'd have an internal moment that would reflect that challenge. And the angles are kind of make sense. So essentially for the lumbar angle, for the lumbopelvic position or the anterior tilt position, there was much more extension, upwards of 20 degrees in the lumbar spine, versus for the slump test, there was 5 degrees on average, 5 to 10 degrees. And then in the thoracic angles, they varied mostly with they were much more extended for here, looking here, much more extended for the thoracic position, or like the normal position, and flexed for the other 2 positions. Finally, we look at EMG, and so again, this is the difference, or the percent MVIC for this is the neck extensor muscles, upper trapezius, and then the thoracic spine, erector spinae muscles. And we can see is for the extended position or the thoracic position, they were relatively small, around 10 or 15%. And in this study, there's only a slight increase in EMG with the slump sitting position. And then over here, we have the thoracic spine muscles were really required to do this extension here. So if we look here at the angles, there's like a 10 to 15 degree extended thoracic spine. Well, it took some muscle activity to achieve that, although still it's pretty low level because there's not much external load going on in that moment. So what this just gives you as a picture of is the key take-home messages are that lumbar position affects strongly some of the muscle activity in the neck and the loading that's going to occur at the joints. And for this reason, the slump sitting position is usually is not promoted, and because we have like passive loading throughout the lumbar and thoracic spine, and then active loading of the neck, which can contribute to like headaches and things like that over if held for long enough. And then the consequence of like a thoracic or a lumbopelvic position is that we saw increased activity here in the thoracic region for the thoracic posture. If we would have measured lumbar EMG, we would have also seen increased lumbar EMG for the lumbopelvic posture. So these two postures take active muscle contraction to oppose the effects of gravity, and that's why over time, if we sit long enough, most of us end up in a slumped position because the muscle fatigue kind of sets in, and then we kind of assume these different postures, especially in the thoracic flexion.